Hello, today I'm going to talk about the cardiac cycle. It happens in four main stages. The first stage that I'm going to start with is stage number 1. I'm going to start with atrial contraction. So let's have a look at this in a little bit more detail. So atrial contraction, as the name suggests, is when the atria contract. They receive a message from the SA node, which is a bunch of pacemaker cells, that causes the muscle of the atria to contract, which is denoted here by these red arrows here. Okay, so the atria contract. What this causes to happen is the space or the volume to decrease or get smaller. And what happens to the pressure, as we can see on this pressure graph over here, is that it causes the pressure to increase in the atria, both the left atrium and the right atrium. So the pressure is increasing here, which forces the blood from the area of high pressure to where it's lower in the ventricles. And as you can see, the AV valves, which are the valves between the atria and the ventricles, are open in this situation because blood is being forced through from the atria into the ventricles. What's happening in the ventricles then, in terms of pressure, is that pressure is slowly starting to increase as the blood flows into the ventricles. Because there's blood in there, the pressure increases in the ventricles as well. Okay, next place we're going to deal with is section number 2, ventricular contraction. So ventricular contraction, like the name suggests, is when the ventricles start to contract. This happens at around 0.1 seconds after the atria contracts. So you can see here 0.1 seconds is when the ventricles start to contract. Also at this point here, at point number 2, you can see that at point 2, the left ventricle, the ventricular and the atrial pressure are exactly the same, and it's at that point that ventricular pressure increases above atrial pressure. So you can see in this diagram on the left here that the pressure in here is now higher than it is in the atria. So the pressure in the ventricles is higher in the ventricles compared to the atria. And so what this forces to happen is these AV valves, you can see them, are now closed. Because remember, valves prevent the backflow of blood. So they close when it starts to go, this blood wants to get from higher to lower pressure, it forces those closed because we can't have backflow of blood happening in the heart. So this is what's happening at point number 2, where ventricular pressure exceeds atrial pressure. It forces the AV valves to close, producing that boom, that first sound of the heartbeat. Now the second thing that this ventricular contraction is causing to happen, we can see here that those walls are squeezing inwards, causing that space to become smaller. It further increases the pressure. So this is what's happening at number 3 here. That pressure in the ventricles is really, really increasing a lot. You're really squeezing that muscle of both sides of the ventricles, which further increases this really, really high pressure. At this point, point number 4, we can see that the ventricular pressure now exceeds that of the aortic pressure. So at point number 4, the pressure in the ventricles is now higher, becomes higher than that in the arteries, your aorta and your pulmonary artery. So if we look on the graph again, our pressure in our arteries is comparatively lower at this point, which then forces those SL valves open. So at point number 4, the SL valves open, and that blood is now squeezed from the ventricles into the arteries, and so you can see that in both of them, the pressure is increasing. The aortic pressure is increasing, pulmonary artery pressure will be increasing as well, but it's lower than the ventricular pressure. Now, as the blood is squeezed out of the ventricles and then continues to be squeezed out of the arteries, the pressure starts to decrease again. So this is what we're seeing happening here in both the the arteries and the ventricle is at around 0.3 seconds, the pressure starts to decrease again in both. Now we will move on to stage number 3, which is the relaxation of the ventricles. So flash forward to here. So we're now at a point where the pressure, coming up to around point number 6, where the pressure in the ventricles has started to, well, at point 5 it has already started to decrease, but at point 6 is where the ventricular pressure decreases below that of the aortic pressure or the arterial pressure. This is because the wall is relaxing, and so your volume is increasing again. The blood is now left there, so your pressure is really decreasing, and it gets to a point at point number 6 where the ventricular pressure drops below the arterial pressure. So relatively speaking now, after point 6, the pressure in the arteries is relatively high compared to that in the ventricles. And so again, what will happen is that blood will want to try to flow back from high to low pressure, which forces those SL valves, those semilunar valves, to shut to prevent that backflow of the blood. And so this, at this point number 6, is that second dub sound that you hear, lup dub, boom, 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 boom. It's the sound of your SL valves. The second heartbeat is the sound of your SL valves closing. And now we move on to the final stage, stage number 4. Both the atria and the ventricles are now in a relaxed state, and blood is coming back into the heart from the body. It's filling back in again. So we're at this final point now where we have the ventricular pressure, which is dropping, dropping, dropping. Ventricles, as like I said, ventricles and atria are relaxed. And at point number 9, we have another big event here. We see at point number 9, the ventricular pressure drops below that of the atrial pressure. So the atrial pressure is this one here, and the ventricular pressure is now dropping below that. So relatively speaking, our atrial pressure is higher than that of our ventricles. So point number 9, those AV valves open again as blood comes from the body back into the atria and fills that up, which causes an increase in pressure here. Comparatively to the ventricles, it's higher, and it forces those AV valves open again. As the blood is coming back from the body, you can see that at point number 10 here, the pressure in both start to increase slowly, and we get back to point 0 again, where we start the cycle all over again. This whole process takes around 0.7 seconds, so it's less than a second for each heartbeat.